using my phone as my object. Okay, I've been using my phone as my object, you know that. So we're still going to use it here, and the reason why I said I use the phone is because it has very good lighting. Okay, so you can see on there's a screen I've put. There's a screen here. I'm gonna just hold it in my hands because of for the purposes of varying the distance. Okay, so my phone, I've pressed the phone at 40 centimeter mark. It is resting at 40 centimeters mark. There is a cartoon running, so don't worry, it is going to be our object. And then the focal length we said is 5 centimeters. Okay, so the first place I'm going to put is at 30. So that takes us, so we're going to look for the image. So I'm going to move the screen until I get a very sharp image of that object. Okay, so the image, I'm going to move it again to and fro. You do that, exactly what I'm doing, you move to and fro until you get a sharp image of the cartoon on the screen. Now my image, if you can be able to read the meter rule, is around 20. The sharp image is around 20. So from 30 to 40, that is my object distance, and from 20 to 30, that is my image distance. So the object distance is 10 centimeter and the image distance is also 10 centimeter. You understand why? If the focal length is 10, then the radius of curvature is 20. Therefore, I've placed my object at the center of curvature. And then if you put your object at the center of curvature, you expect to form the image at the radius of curvature on the other side. And what are the characteristics of the image? The images are true, they are inverted, of course, they are at the center of curvature, and they are the same size. Now, if you take a good look at my image, you observe that it is the same size as the object. So when I put the lens at 30, when the object is at 40, then I'm forming my image at around 20. And the image is sharp and very clear. Okay, very good. So we can take our first recording. Our first recording is so I just record on the paper here. I just record on the screen. So U is 10 and V is also 10 centimeters. Okay, now I'm going to change my object distance. So this time I've put the object distance to be 10. Now I'm going to put my lens at 25. Okay, so 25 to 40, that is an object distance of 15. So let's look for the image together. So again, I'm going to remove my screen until I observe a very sharp image. Now can you see it? Very nice one. Okay, so that's the image. I hope I'm able to focus properly. That's the image. Let me lose it again. Then I come forward. Then there. Okay, you can see the sharp image of my cartoon. Sharp image of my cartoon. And where is it forming? It is forming around, that's 19, 18. It's forming around 17. Okay, so 17 to 25. That's what? 5, 6, 7. That's around 8 centimeters. So image distance is 20 centimeters when the object distance is 15. So we can record that also. So when U is 15 centimeters, V equals to 8 centimeters. So that is our second reading. When V is 15 centimeters, when U object distance is 15 centimeters, then the image distance, we have found it to be 8. Okay, so I'm going to vary again my object distance. So this time, I'm going to put the object at 20 centimeters mark. Okay, so from 20 to 40, where the object is, that's a distance of 20 centimeters. So I'm going to vary the screen again until I get a sharp image. Okay, so I vary. Okay, so can you see the image? Very good, nice. That's the image. Let's see where it's forming. It's forming around, that's around 14 centimeters. Very nice one, very sharp. So it's forming around 14 centimeters. Okay, so 14 to 20, that is 6 centimeters when the object distance is 20. So we record that also. So when U is 20 centimeters, then V is 6 centimeters. Okay, I've recorded that. When U is 20 centimeters, then V is 6 centimeters. Okay, so we can do the last one. Let me move my object now. I've moved from 10 to 15 to 20. So let me move the object 25 distance from the length, 25 distance from the object. So that is 35, that is 20. So I'm going to put it at 15 centimeters. So again, now remember, I hope you're getting how we are going. As we move the object far from the lens, meaning the object is falling behind C, then the image is coming closer to the lens. Okay, so we are looking for the image now. We're looking for the image till it's very sharp. Okay, and there it is. The image is at 10. Now I'm at 10 centimeters. The image is very sharp. I'm at 10 centimeters. The image is very sharp. I hope you can see on the screen. So my screen is facing my camera is facing the screen right now. It is not facing my phone. So that is the image. What can you say about the image? One, it is very small. It is smaller than the object. It is inverted. It is true. That's why it is inverted. But most importantly, it is smaller than the object. Now, where is it forming? Okay, the object is behind C, so the image must be forming between C and F. The image must be forming between C and F. But now this time, remember we said the object, the focal length is 5, and this object image is forming at 10. My lens is at 15, and the object and the image is forming at 10. So from 10 to 15, that is 5 centimeters. So what does that mean? It means my object is forming at the focal point. Okay? It's forming at the focal point. So meaning an object at 25 centimeters is at infinity. Remember, objects at infinity is the ones that their images form at the principal focus. So now my object is at infinity. So anything beyond 25 centimeters is infinity. 25 and above is infinity. So we're going to record that also. So now we have it when we U 5 centimeters, V is 5 centimeters. So we are going to call that infinity. Going to fold that infinity. Maybe we can take our last reading. In our last reading, I'm going to bring the object and the lens anywhere. I'm not going to be specific, but I want to make sure that the lens is closer to the object. Let's see what we form. Okay, so I put my my lens at 29. Let me put it further. It's at 27 now. So let's look for the image. Must move until the image is very, very clear, very sharp, and is around there. Okay, at 21. Okay, so my object is at 27 and the image is at 21. So let's measure 27 to 40. That is 13 centimeters. Object distance, and the image that is in the same is at around 21, no 20, so 20 to 27, that is around what? That's around 5, that's around 7, okay? 7 centimeters, okay? So we record that. So 13, when U is 13 centimeters, V is 7 centimeters. So that's what we have, viewers. 13 centimeters. So I have everything here. We have taken 5 readings from our experiment. Some images are bigger than the object. So just you put the screen anywhere and you vary. You can fix the lens and move the screen, or you can fix the screen and move the lens. Whatever you choose. Whichever you choose to vary, whether it's the screen or the object, either way you are going to have the image distance and the object distance varying. Okay, so for me, I prefer to fix the screen and the object and vary the lens, but either way you still get the same results. Okay, so you move until you're able to focus a very sharp image on the screen, like the one I'm having right now. Okay, hope you're able to focus on the screen properly so that you see. So you can see that image very sharp. You can see the cartoon and everything that is they are doing there. Okay, so that's a very sharp image. So all your images should be like that, so that now you are able to take the readings. Okay, so that takes us to the end. So let's focus on our screen. So we have one object distance is 15, the V is 8. When the object distance is 13, V is 7. When the object distance is 10, V is 10. When the object distance is 20, V is 6. And when the object distance is 25 and above, that is infinity, V is 5 centimeters. So those are 5 recordings we have taken. And from that recording, you can plot a graph. You can put them in a nice table. Remember, I was using my screen. So you can put a table of U against V. And remember, everything is in centimeters. Then you